Hello students, welcome to this class of industrial engineering. So until now we have studied about the graphical method to plot the linear programming problems, right? So we already know that why we use linear programming, right? We use the linear programming for the optimization problems, right? Like let's say in industry we have certain situations where we can have variable machines and we can have variable manpower and we need to minimize our cost and maximize our profit. So how we can do that? We basically write the equations, right? We have already done it in earlier classes. Like we will be given equation for the manpower, like how it will impact the cost, and then we will also be given the equations for the machines, right? Like what is the cost price of each machine and how it impacts our production, and then there will be a final equation that will tell us that how it will impact the overall cost. Then from these both equations, the both variables, we write the optimization problem. Okay, and in last class we have done this graphically. Now, in last class, we have discussed when we got the solution, right? But this is not always the case. So, in this class, we are going to see that what are the various types of solution that we can face while we are solving such kind of problems. It's not always the case that you will get the optimum solution or there will be a solution always. Right? Sometimes there is such a case that the solution doesn't exist. The problem is such that the solution doesn't exist. It is also possible, right? How it's possible? Let's say I have two equations, okay, and and let's say I know that for to work on one machine, at least one man is required. Now, if in my problem I am saying that minimum amount of machines that I need is 25 and the maximum amount of men that I can have is 10. So that's not reasonable because these both statements are conflicting with each other, right? How we can have only 10 workforce people and we want to work on 25 machines? This is not possible, right? Uh, yeah, so there are many kinds of solutions. So we will see in this class. Okay, so this is our today's topic. That what are the types of solutions? Right now, see now until this time we are seeing only if we have two equations, right? I'm not going with many equations. We will see it in further classes that while studying simplex method, that how to solve for those problems. But as up till now, I'm talking only about graphical method. And now let's see what are the types of solutions. So what's it written here? That depending upon the feasible reason, you already know what feasible reason is. Optimum solution can be of following types. What are the types of solution? First one is definite and unique optimal solution. Second is infinite optimal solution or multiple optimal solutions. Other is solution is unbound. Another one is no feasible solution or infeasible solution. And next is single solution. So let's see now what is each one of them means, right? So the first one is unique solution. So what's written here? Z has unique value at particular point, which normally is corner of feasible region. Okay, so we have written the optimization problem in last class. You already know what Z is, right? We need to optimize the Z, right? It could be a maximization problem, it could be a minimization problem, depending upon the data. And so yeah, in last class we have solved the problem in which we have seen that there was clearly 4 to 5 points, 5 corner points that we were getting, and out of which when we were doing maximization problem, we have seen that the point that was the farthest from the origin was the was our solution, and it has a unique solution, right? It has the unique solution. Like I will show you the case, the problem that we have solved in last class. Yeah, this one, right? So in this one, what we did in last class was we got these points, right? Like the one is this point, then this point. We got these points. So we know that out of these 4 5 corner points, like as we have already studied, one will be a optimal solution. We check the values on each solution. We calculate the value of z for each corner point, and we find out that C is my maximum point. If this was a maximization problem, then C will be the answer by this C point. And if this would have been a minimization problem, then A would have been the answer. Okay. So yeah, it's simple. So this is what unique solution means. Means your equations are such when you plot all the equations on a graph. right, on XY coordinate Cartesian plane, you find out that you got the very clear corner points, and on a certain corner point, you are getting the maximum value, which is your solution, or you're getting the minimum value, which is your solution, right? Okay, so I will leave it here as of now. So yeah, now you know what definite and unique optimal solution means. Okay. So now the second point is multiple solutions optimal. What this means? It is saying in this case solution is not at the corner but at particular line parallel to isocost line. This line must be on visible region. So what does this mean? So as we have studied in last class, what we have said over here that the most optimized point my solution will be the point that is farthest from the iso coastline, right? That is farthest from the iso coastline. Now what's multiple solution means? Sometimes a case might arise when you have many farthest points, right? Like this could be the case. I will show you. Like I have let's say I have this Cartesian plane, okay, and let's say this is my iso coastline, okay. Now rather than having a point that is at farthest distance, let's say I have an equation that is parallel to this iso coastline. Now the problem is that the distance of every point from this line is same, right? The distance of this is my iso coastline, okay. So now the problem here is that the distance that I have got multiple points, right? Like this is also a point, this is also a point, and all are the optimal solution. All are the optimal solutions because they are at the uniform distance from the isocost line. And we know that the farthest point from the isocost line is my optimal solution. And here I am getting many such points. So this gives me multiple solutions. Okay. So this gives me multiple solutions. That's what is the in this case solution is not at the corner but at particular line parallel to isocost line. That's what I'm saying, right? This line must be on feasible region. Yeah, obviously. Okay. So now the next is unbound solution. Now what's unbound solution? Feasible region is unlimited and open, hence Z may have very large limitless values. Now the situation could be such that sometimes to get the optimal point, to get the solution, our region must be enclosed, right? Like in this case, what was happening? I was getting this green shaded area, which was enclosed. So I know that this is my only feasible area, and my solution must lie at one of such boundaries. Okay, boundaries or corner points. I just need to find out that. But sometimes our equations are such, like I will show you. Unbound. Yeah, like in this one. Like in this one, this is unbound. What unbound means, now what we said that farther from the Z region, no, it has no limits, right? My this area has no limit. It will keep on increasing. So the as you keep on increasing the value of coordinates, your solution will keep getting optimized. There is no limit to the values of x1 or x2 that you will get the optimum solution. It's just like as much as you add the sugar, the more sweet will be your tea. So there is no limit to such sweetness, right? As much as sugar you keep on adding the sugar, and you will keep increasing the sweetness of the dish, right? So that's the scene. However, that's there is also a limit. After a certain point, you will not like that taste. But yeah, for the just to understand this matter, what I'm saying, yeah, like if you keep on increasing the values of x1 and x2, and your equation, your optimization problem keep getting optimized. So there is no bounded reason so that you can give the value to a person that yeah, do you choose such so many of machines or so many of manpower? You can't do that in this case, right? So yeah. Okay, so now you know what's unbound solution is. The unbound solution is different from infeasible solution. Okay, in unbound solution we have the solution. It's not that we do not have the solution. It's just we do not know where to stop. It's infinite, right? So that's what I'm saying. Okay. Now the next one is infeasible solution. So this is different from unbound solution. That's what I'm saying. But infinite solution is no solution as the constraints are conflicting and or are inconsistent, right? What it means that sometimes it might be possible that the way that you are giving the constraints, the way that you are demanding the things from your system, it's not possible to have a solution, right? Now let's say we want to install a lab in our college, okay, and I have a machine that I need to install, right, like which is very long in length, okay, which is very wide in area, and I have a stairs, I have a narrow stairs. Now I give you a problem, you're being the students of this college. I give you a problem that, okay, students, we need to install this machine in our lab on the top floor of our college. You say, okay, sir, but now the problem is I have the lab on the top floor and I have the machine on the ground floor. Now I need to take it upstairs, but the thing is the stairs are narrow. You can't take it, it's impossible. So it's a infeasible solution. You will say that, sir, it's not possible. I want to do, I have both the I have both the conditions, but these conditions can't be met. We need to make some changes. We need to either we need to dismantle this machine, or we need to install this on the ground floor, or we need to make arrangements for a new labs. But the way you have given the constraints that we have to install this machine on the top floor, it's not possible. So that is the case with infeasible solution. Okay, so I will show you the example of infeasible solution like this one. This one is infeasible solution. Okay. Now what this says, like one we have area in this direction, another we have area in this direction. Now they will never meet, right? This is such a nonsense. Like they will never meet. We will never have the optimization. Okay. This one is directing upwards, one is directing downwards. We do not have the feasible reason. So when we do not have any feasible reason, we can't expect any feasible solution to happen, right? So this is a case for infeasible solution. Now the last one that remains with us is the single solution. So what is single solution? Sometimes the constraints are such that they only like if I have the two like I have two situations. Let's say I have two equations, and they both strike once like this. Then this is the only solution. It might be optimal, it might be not. You will say that, sir, there is only single way to do this task. It's your problem whether you want to do it, whether you do not want to do it, but there is just a single way to do this task, and this much it will cost. Now it's your call whether you want to do it or not want to do it. That's the problem with single solution. You know, sometimes it happens that when we want to get some work done, like we call the electrician, right? And I want to get my fan repaired. Now the electrician will, let's say the electrician says you that, sir, my visit charges are 1000 rupees. It doesn't matter whether you have one fan to repair or 50 fans to repair. I will charge for my one day task, I will charge 1000 rupees. So there is only a single solution. Now, how will you decide whether it's worth it or not? Now it's your problem. Now, if you have just one fan to repair, you will say that why will I call the electrician? It will be very costly for me. So what you will do? You will dismantle the fan, you will take it to the shop because that might be cheaper for you, right? Now that's your call. Being a manager or being responsible for that task to be done, it's your call that how you proceed with that task. But yeah, the solution you have is single one. Like there is one cost, there is only one optimum solution that you will get, right? So this is a single solution. Okay. So these were the various types of solutions while solving the optimization problems. Keep it in mind. First one is unique solution, optimal solution, right? Another one is infinite optimal solutions or multiple optimal solutions. Next one is unbound solution. Another one is no feasible solution or infeasible solution. And the final one is single solution. Okay. I hope you get my point. We will meet in next class. Bye.